Okay, okay, we have already seen that from the previous video that export and GDP are co-integrated, so we can easily run the VECM model, and that we shall do now. Okay, so I have to go to statistics to run it. Okay, so what I do, I make it clear and I run it. I make all clear. Okay, I go to statistics, multivariate time series, then vector error correction model, and here we set the variables. Okay, first I take the export and then GDP. So here I have taken export first intentionally, because that will be my error correction model, and export will become dependent variable, and that is why I have put export first intentionally. And maximum lag I should put also 5, right, as before, and here I put constant, and time settings it is already here, observation and yearly data, right. Then I press OK. Okay, then everything is set. Then I proceed with the OK. So the result has come up. You can see the result of the vector error correction model, right. Result, vector error correction model when, okay, so these are the results you can see. Okay, and here out of this result, our target variable, actually the first one, export, right, and that is my target model. That is our target model. And here you can see D export. Okay, and normally what happens, the VECM model automatically convert the variable into first difference. So actually last time I put export has become D export, meaning that first difference of export. Okay, and here export is the dependent variable, and these are all independent variable. You can see export lag 1, lag 2, lag 3, lag 4, GDP lag 1, lag 2, lag 3, lag 4, and constant. These are all independent variable. And what about this one? This one is the co-integrated equation 1. CE1 means co-integrated equation 1. Okay, because we have one co-integrating equation or one error term. Only one error term we have in this model. Okay. And here you can see the coefficient, standard error, z value and p value. So this is the coefficient and this is standard error. This is z value, z statistics, right? Okay, and what is the guideline? Coefficient 1.6 divided by standard error 0.44 is always z statistics. That means minus 3.64, meaning that this divided by this you can get the z statistics minus 3.64. And also here this one divided by this one you can get 2.69, and this is corresponding probability. These are all probability. Okay. Okay, and here is two issue. One is long run causality and one is short run causality. Okay, there are two issues. Okay, so first I talk about long run causality. What is it? Okay, here you can see the co-integrated equation 1. This coefficient actually error correction term, right? And this coefficient or this coefficient is significant because the p-value is less than 5%. So here what is happening? Error correction term has negative sign and also significant, meaning that there is a long run causality running from GDP to export. So the whole thing I am telling again, when the error correction term has negative sign and when it is significant, meaning that there is a long run causality running from GDP to export. Okay, that is long run causality. Okay, now we can talk about short run causality. Okay, from here you can see these are our short run coefficient. What about this one? Short run coefficient. This is short run, short run, short run, short run, short run, short run, short run. These are all short run coefficient. Okay, and suppose I talk about this one, export lag 1. This variable is significant, right, because it is less than 5%, right? What about the export lag 2? It is 14.4%, so it is not significant because the the probability value is more than 5%. And what about this one? GDP lag 1, it is 9.9%, which is more than 5%. So it is not significant to explain our export variable. And what about this one? Lag 4 of GDP. The probability value is 47.1%, which is more than 5%, meaning that lag 4 of GDP is not a significant variable to explain our export. What about this one? Export lag 4. It is not also significant, meaning that export lag 4 cannot influence export, which is dependent variable here. So here we can see in the short run export lag 1 is significant, and then I think only one variable is significant, right? That is this one, export lag 1, to explain the export, right? Okay. Now we talk about short run causality. That means as a whole, right? Short run causality from GDP to export, right? That we want to check. Okay. The question is that how to check short run causality. So I go to statistics, then I go to post estimation, then test linear hypothesis, right? Okay. Then create, then I put coefficient in specific equation are 0, that I select, and here export is our dependent variable, and test these coefficients, right? Okay. And GDP, right? We take lag 1 of GDP, lag 2 of GDP, lag 3 of GDP, and lag 4 of GDP. We have 4 lag of GDP, right? And whether all these 4 can cause export or not in the short run, that we want to know, right? Okay. So I click OK. So then I press OK. Okay. So it is the null hypothesis that they are 0, right? They are they are jointly 0, right? They are all 0 to explain export, right? That means LD GDP, L2D GDP, L3D GDP, L4D GDP, they cannot explain D export. That is the null hypothesis, right? That means they are all equal to 0, right? Okay. And the value of chi-square is 4.79 and probability is 30.94%. 30.94% means more than 5%, meaning that we cannot reject null hypothesis, meaning that they are all these variables are 0. That means there is no short run causality running from GDP to export. Why? Because all these four, lag 1, lag 2, lag 3, lag 4, all are jointly 0, right? So GDP cannot cause export, meaning that there is no short run causality running from GDP to export, because these are all short run coefficient. So that is why here I am saying short run causality. So there is no short run causality running from GDP to export. But there is a long run causality from GDP to export that we have already seen. Okay. And now we can talk about how is our model. That means whether our model has serial correlation or not, whether the residuals are normally distributed or not, that we can check. Okay, and also here I said this one minus 1.602917. Actually this one is error correction term. Also this one is called speed of adjustment towards long run equilibrium. This minus 1.60, this also means speed of adjustment towards long run equilibrium. Okay. Now we check that diagnostic portion of this VECM model. Okay, first I check whether there is autocorrelation or not. So I go to statistics to check it, then multivariate time series, then VEC diagnostic test, then LM test for residual autocorrelation, right? I click here. Okay, here I keep 2, maximum order of autocorrelation, I keep 2, then I check. Okay, so actually this one is the command, right? Command. Okay, so this is the outcome, Lagrange multiplier test, lag 1, lag 2, because we have taken only 2 lag. And what is the null hypothesis? There is no autocorrelation at lag order. But lag 1, the value is 4.197, 4.1%, right? Meaning that we can reject the null hypothesis, meaning that there is autocorrelation. But at lag 2, the p-value is 83.63%, meaning that we cannot reject null hypothesis. meaning that there is no autocorrelation. But lag 1 got autocorrelation. So we can say that this model has autocorrelation, and that is not desirable, and we cannot accept the result of this model because there is serial correlation or autocorrelation, and they are same meaning. So we cannot accept this model. We have to redesign the model so that there should not have any autocorrelation. Okay, then we check about whether the residuals are normally distributed or not. I go to statistics, multivariate time series, VEC diagnostic test, and test for normally distributed disturbance. I take it, and here I choose only Jarkabera statistics, right, to check Jarkabera statistics. Yes, and here you can see there are this is Jarkabera test, and export is our target variable, and p-value is very small. That means it is less than 5%, meaning that we can reject the null hypothesis. And what is our null hypothesis? The null hypothesis is the residual of this model, of the export model, is not normally distributed, and that is not desirable. Normally the residual should be normally distributed. And here as a whole all, right, because we have two model, and this is as a whole, we can reject the null hypothesis because the probability value is less than 5%, meaning that the residuals are not normally distributed, and that is not desirable. So we cannot accept accept this model as a whole because residuals are not normally distributed. So that is the bad sign of this model also. Thank you very much for being with me for a while. Okay, in the next video I shall talk about GDP. Thank you very much for being with me for a while.